Track 43.
Unit 3. Science Everywhere.
On these pages, you will read about interesting and simple science demonstrations you can do at home with your friends, like making a zip bag explode or building an electric motor. There is a difference between a science demonstration and a science experiment. The latter one is done to compare results. For example, you ask a question such as, "What fertilizer is the best?" and then perform different experiments to get the answer. A scientific method is always required to reach an answer or solve a problem. The following are the different stages in the method. 1. Purpose. Question. This is the first step. To ask yourself a question you want to find the answer to, such as, how does the color of light bulbs affect the growth of plants? Or, are artificial sweeteners as sweet as real sugar? 2. Research. Now you find as much information as possible about the question you asked before actually experimenting. You can ask your science teacher, surf the web, and look for information in books and encyclopedias. 3. Hypothesis. Once you have researched, formulate your hypothesis. For example, if I do X, then will Y happen? 4. Experiment. Now you are ready to truly experiment. First, you have to think of a procedure to test your hypothesis, and once you carry it out, you have to write down exactly what you did in each step of the experiment. 5. Analysis. Record all the information related to what happened while you performed the experiment. It will be the data. 6. Conclusion. Go over the data to verify if your hypothesis is correct or if you were wrong. The exploding lunch bag. Materials. 1 small Ziploc bag. 3 teaspoons of baking soda. 1/4 cup of warm water. 1/2 cup of vinegar. Measuring cap. A tissue. Procedure. 1. First, put the water into the bag. It must be quite warm. 2. Then, add the vinegar to the water. 3. Next, put the baking soda in the middle of the tissue. 4. After that, fold the tissue around the baking soda to wrap it up. 5. Then, you will have to be quick to do the following. Zip the bag partially, leaving enough space to add the baking soda packet. Put the tissue into the bag and zip the bag completely closed. Do this fast. 6. Finally, put the bag in a sink or on the ground outside and step back. The bag will start to expand and then explode. The baking soda and the vinegar mix. The purpose of the tissue is only to allow you some time to zip the bag shut. Once they mix, an acid-base reaction is produced, and the two chemicals create a gas called carbon dioxide. As gases need a lot of space, once the carbon dioxide has filled the bag, it still needs more space, so it produces an explosion. Turn this demonstration into an experiment by formulating one of the following hypotheses. Will different temperature water affect how fast the bag inflates? Which size bag creates the fastest pop? If I change the amount of baking soda, how will the reaction change? A tabletop hovercraft. Materials. An old CD or DVD disc. A 9-inch balloon. a pop-top cap from a liquid soap bottle or a water bottle. Hot glue. Procedure. 1. Cover the center hole of the CD with a piece of tape and make 6 holes in the tape with a small nail. The purpose of the holes is to slow down the flow of air for your hovercraft to hover longer. 2. Glue the cap to the center of the disc with the hot glue. 3. Blow up the balloon and pinch its neck. Don't tie it. 4. Make sure the pop top is closed and fit the neck of the balloon over the pop-up portion of the cap. 5. Put the craft on a smooth surface and open the pop top. Explanation. The airflow made by the balloon causes a cushion of moving air between the disc and the surface. This makes the CD go up and reduces the friction, making the disc hover freely. Turn it into an experiment. Answer the following questions. 1. Does a helium balloon work better than an air balloon? 2. Does the size of the disc affect the performance of the hovercraft? 3. Does the size of the balloon affect the CD's ability to hover?
How to make a simple electric motor. Electric energy can be converted into mechanical energy by machines called electric motors. They work due to electromagnetic interactions. The interaction of current, the flow of electrons, and a magnetic field. Materials. D battery. Electrical tape. Insulated 22-gauge wire. Knife. 2 large-eyed, long metal sewing needles. Small circular magnet. Marker. Modeling clay. Procedure. 1. Start in the center of the wire and wrap it tightly around the marker 30 times. Then slide it off the marker. 2. Wrap each loose end of the wire around the coil a few times to hold it securely. Make sure both ends of the wire are directly opposite each other on the coil. 3. Use the knife to remove the top half of the wire insulation on each free end of the coil. Make sure the exposed wire is facing the same direction on both sides. 4. Thread each loose end of the wire coil through the eye of the needle. Don't bend the wire ends. 5. Stick some modeling clay on either side of the battery so that it doesn't move. 6. Cover the sharp points of the needles with a little bit of modeling clay. 7. Place the needles upright and make the side of each needle touch one terminal of the battery. 8. Secure the needles with electrical tape to the ends of the battery. The coil should hang above the battery. 9. Tape the small magnet to the battery so that it is just under the coil. See how your coil spins. Explanation. The metal, needles, and wire form a closed-loop circuit that can transport current. Current flows from the negative terminal of the battery through the circuit and to the positive terminal of the battery. Current in a closed loop also creates its own magnetic field, which you can determine by the right-hand rule. Making a thumbs-up sign with your right hand, the thumb points in the direction of the current, and the curve of the fingers show which way the magnetic field is oriented. Here, current flows through the coil, which is the armature of the motor. This current induces a magnetic field in the coil, and that's why the coil spins. Magnets have two poles, north and south. North-south interactions stick together as the magnetic field created by the current in the wire is not perpendicular to the magnet taped to the battery. Some part of the wire's magnetic field will repel and cause the coil to continue to spin. The insulation was removed from a part of the wire to periodically break the circuit and to make it pulses on and off in time with the rotation of the coil. The coil will continue to spin until the battery is dead. Turn this demonstration into a real experiment, answering the following questions. 1. What would happen with a bigger magnet? 2. What effect will cause a bigger battery? 3. What about a thicker wire?
Desalinization. Materials: bowl, water, tinfoil, large pot, spoon, ice, salt, boil-safe mug, stovetop. One. Mix salt into a big bowl of warm water. Keep adding salt and stirring until there is some salt left on the bottom of the bowl which will not dissolve. 2. Pour the salt water into a large pot on the stove. 3. Place the boil-safe mug inside the pot. 4. Cover the pot with tinfoil, sealing the edges. Leave a slightly lower point in the middle where you will place some ice cubes. 5. Turn the stove on and boil the water. 6. When the water starts boiling, set it on low-medium heat to keep it simmering. 7. Let simmer for about 10 minutes or until the ice cubes melt. 8. Turn off the heat and let the water cool for half an hour. 9. Remove the tinfoil. Now there is water inside the boil-safe mug and a lot less water in the pot. Try the evaporated water in the safe mug by dipping a finger in it. Then try the water remaining in the pot. You will notice this one is really salty. Testing water density. Materials: 2 test tubes or small containers. Food coloring, 2 colors. Eyedropper, 2 jars. 2 small potatoes. 1. Add a bit of food coloring to each type of water, the one in the safe container and the one in the pot. Use 2 different colors. 2. Add a bit of salt water to a test tube. Then using the eyedropper, add some of the water from the safe mug to the test tube, 1 drop at a time. You will notice that the fresh water layers on top of the salt water. 3. Try putting the fresh water from the mug first in a test tube. Then add like you did before, drop by drop of salt water. Now both types of water mix completely. 4. Continue testing the density by putting a small potato inside a jar with fresh water and another one in a jar with salt water. The potato sinks in the fresh water but floats in the salt water. Explanation: when you boil salt water, it creates steam. That is water in gas form, which rises during the boiling process and escapes into the air. But as the pot was covered, the steam was kept inside. The ice makes the steam cool fast and directs the cooled water into the mug. The salt is left in the original water in the pot, but it becomes more concentrated as molecules of H2O escape through evaporation. As fresh water is lighter or less dense than salt water, it will remain on top of the salt water in the test tube. When you put fresh water first and then salt water, as it is heavier, it will go to the bottom and mix immediately with the fresh water. The high density of salt water makes the potato float. That is why it is easier to float in the ocean than at the pool. A fog tornado. A shoebox with lid. A small 12-volt computer fan. A piece of clear plastic 25 centimeters by 43 centimeters, or clear plastic food wrap. A small plastic food container. Dry ice. Black paint. 9-volt battery. Battery-powered tap light, optional. Instructions.
1.
Cut the box according to the diagram below, cutting away the areas marked in gray. The opening at the top should be a bit smaller than your fan. The one at the bottom should be bigger than the plastic food container.
2.
Paint the inside of the box with black paint and let it dry.
3.
Tape or glue the clear piece of plastic in the large window on the front. Keep the slot open so air can flow through it.
4.
Attach the tap light to the inside of the top of the tornado box, near the fan opening.
5.
Turn on the battery-powered light and power up the fan. Place it on top of the chamber with the breeze blowing up.
6.
Create fog by putting some small pieces of dry ice and some warm water into the food container. Dry ice is dangerous. Always wear thick gloves to handle it and wear safety goggles.
7.
Put your tornado chamber over the container and watch the vortex currents work.
Explanation. The fan forces air out of the chamber, and at the same time, airfoam outside the box is forced in through the slots. Because of the position of the slots, the incoming air creates a vortex, a spiral, of air as it is pushed up and out of the box. Real tornadoes use updrafts and wind from different directions at different heights. Turn this demonstration into an experiment. Answer these questions. 1. Can you control the shape of a tornado if you cover parts of the slots? 2. Can the shape of a tornado be changed by a faster or more powerful fan? 3. What happens when you use a bigger box?